Did you know that every year, the aviation industry serves more than 1 billion meals at altitudes above 10,000 meters, where constraints of space, time, and safety are pushed to their strictest limits, driving production and operating costs far beyond those of meals prepared on the ground? But have you ever wondered how such a complex system actually operates? That journey begins on the ground, with agriculture and carefully selected raw ingredients, passing through food processing plants and specialized industrial kitchens dedicated to aviation catering. Here, every dish is designed to adapt to cabin pressure, low humidity, storage time, and the changes in human taste perception at high altitude. Once completed, millions of meals each day enter a tightly controlled process of chilling, logistics, and precise distribution to thousands of flights, where even the smallest deviation can disrupt the entire system. Join Agriculture Insight as we trace the journey behind airline food and explore how the food industry and aviation intersect to deliver meals served high above the clouds. A meal tray that appears simple on an airplane is in fact the result of a complex value chain that very few passengers ever get to see. In the early decades of aviation, in-flight dining was a symbol of luxury, complete with silver cutlery and hot meals prepared directly on board. But as air travel became increasingly democratized, that model was no longer sustainable, and airline food entered an era of industrialization. Today, most meals are fully cooked on the ground, rapidly chilled, and only reheated at cruising altitudes of around 35,000 feet. In this environment, low air pressure and humidity levels of just 10 to 15%, lower than those of the Sahara Desert, dry out the nose and mouth, dulling the sense of taste. So, if a meal doesn't quite suit your palate, perhaps the kitchen isn't entirely to blame. For leading airlines such as Singapore Airlines, Emirates, and Qatar Airways, in-flight food is part of national identity. Depart from Singapore, and you may be served chicken rice. Depart from New York, and smoked salmon salad is more likely. Naturally, menus also vary by seating class. In first class, passengers enjoy a wide range of options, from caviar to beef tenderloin. In economy class, choices are more limited, often dishes like fish with rice, selected for their suitability for large-scale production. Before a new meal is ever prepared, a vast and largely unseen logistics operation is already at work on the factory floor. For newly landed flights, all plates, trays, and catering carts are unloaded, sorted, and fed into massive industrial washing systems. Each day, this facility processes up to 3 million pieces of tableware, operating with the speed and precision of an engineered production line. Once cleaned, the carts are routed onto a 1.5-mile monorail system that connects every kitchen level, allowing enormous volumes of equipment to move safely and continuously. This preparatory stage lays the foundation for the entire in-flight catering process. Once all equipment has been thoroughly cleaned and prepared for a new production cycle, the operation immediately shifts to receiving fresh ingredients. Unlike meat and fish, which can be stored for extended periods in cold storage, vegetables for in-flight meals must be replenished continuously, because even a delay of a few hours can cause freshness to fall below aviation standards. For this reason, produce is delivered directly from partner farms, stacked on large pallets, and subjected to rigorous inspection right at the warehouse entrance before being cleared to enter the next stage of processing. Our journey begins with the appetizers, where salads that appear simple play a crucial role in opening the in-flight dining experience. To make that possible, we step into the first kitchen of this massive airline catering facility, the vegetable preparation area. Once received, fresh produce must enter the processing line within no more than 4 hours. a strict time limit considered essential to meet aviation freshness standards. Here, vegetables such as cabbage, lettuce, and cherry tomatoes used for salads are pre-cut to standardized sizes, ensuring portion consistency and maintaining the precise rhythm required for the downstream production flow. Beyond salads, this area also prepares a wide range of fruits and vegetables. Bell peppers, melons, dragon fruit, strawberries, destined for different stages of in-flight meals, from main courses to desserts. Once all components are ready, airline salad preparation enters the mixing and finishing stage, where precision defines the final quality. Greens and accompanying ingredients are placed into industrial mixers operating at low speed to prevent bruising. Each mixing cycle lasts only about 90 seconds, just enough to distribute the ingredients evenly while preserving their natural texture. The salad is then portioned and assembled along a large-scale catering line, ensuring consistency across all meals on the same flight. Dressing, a particularly sensitive element in the aviation environment, is rarely mixed directly. Rich dressings such as mayonnaise or traditional Caesar, as well as those high in dairy or butter, are typically restricted because they tend to separate and develop heavier aromas at high altitude. When used, formulations are adjusted by reducing fat content and slightly increasing acidity to maintain stability. Finally, the dressing is packaged separately and paired with components such as chicken breast, chilled pasta, cheese, or toasted nuts, allowing the salad to retain its appearance and flavor until it is served high above the clouds. From the familiar family meal, rice preparation in aviation enters an entirely different world. One where rice is cooked continuously to serve more than 30,000 passengers every day. The process begins with automated rice weighing, where each batch is precisely portioned before being transferred into massive industrial cookers. From there, water is automatically dispensed according to pre-programmed ratios, ensuring the rice maintains a stable structure after hours of chilling and subsequent reheating. In industrial kitchens, rice is not fully cooked, but stopped at around 70 to 80% doneness, enough for the grains to expand without becoming completely soft. Immediately afterward, the rice is rapidly chilled to lock in its structure and prevent further cooking. Once on board, aircraft ovens complete the remaining cooking using residual heat during reheating. While Asian airlines such as Singapore Airlines and Japan Airlines tend to prioritize rice on domestic and regional routes, many European and Middle Eastern carriers consider pasta a foundational choice for long-haul and multinational journeys. To produce more than 1,000 portions of fresh pasta for in-flight service, the process begins with dough mixing in large-scale industrial mixers, where flour, water, and eggs are calibrated with percentage-level precision. The dough is then briefly rested to stabilize its structure before passing through rolling systems and extrusion dies, forming a variety of pasta shapes. From long spaghetti strands to short pasta such as penne, fusilli, and macaroni. Immediately after shaping, the pasta is cooked in industrial boilers holding hundreds of liters, then rapidly cooled to preserve elasticity. For short pasta, the pieces are lightly pre-coated with a thin layer of sauce to prevent sticking and ensure even coverage during reheating. In parallel, sauces are prepared on a separate line. Ripe tomatoes are crushed and simmered in stainless steel vats holding thousands of liters, combined with olive oil, herbs, and precisely measured seasonings. Finally, the pasta is portioned into specialized trays, finished with sauce and sealed with foil to maintain structure, moisture, and flavor until it is served in the air. Beyond rice and pasta, the two familiar pillars of airline meals, dumplings emerge as a more delicate option, typically reserved for special menus on Asian routes such as China, Hong Kong, and Taiwan. The process begins with filling preparation, where time races against each aircraft's departure schedule. Onions and scallions are rapidly processed in the vegetable prep area, then combined with ground meat to create a filling that is uniform in texture. In parallel, the dough is prepared on a separate production line, using specialized starch blends, undergoing controlled mixing and rolling. Rather than relying on manual labor, automated forming systems handle portioning the filling, pleating the wrappers, and sealing the edges with precise pressure, allowing each dumpling to be produced with consistent shape in a short time frame. Before leaving the line, the dumplings are partially steamed to approximately 50% doneness to set their form, ready for subsequent cooling, storage, and final preparation within the continuously operating airline catering chain. In airline catering, most savory dishes are never fully cooked before takeoff. Omelets are one of the rare exceptions. Because eggs are highly perishable and carry higher risks during reheating, omelets served in economy class must be cooked 100% on the ground and only gently reheated on board. The process begins with fresh eggs delivered daily, which are screened for foreign objects, industrially washed, and automatically cracked to eliminate any risk of shell contamination. Yolks and whites are separated and only recombined once, both meet quality standards. The mixture then enters a semi-automated cooking line, where machines precisely dispense oil and egg while human operators control temperature and color. Each batch cooks for only a few dozen seconds before being rapidly chilled, allowing the line to produce over 20,000 omelets per day during peak operation. For business and first-class cabins, pasta or rice paired with salad is no longer enough to deliver a complete dining experience. As a result, airline kitchens must prepare dishes of a higher standard, with filet steak standing as a defining choice of that level of refinement. Inside the premium kitchen of an airline catering facility, the steak is treated as a precise technical challenge, beginning with rigorous meat selection and trimming. Beef is sourced from top-grade fresh batches and subjected to multiple layers of evaluation, including tenderness, muscle fiber structure, and intramuscular fat distribution. Skilled technicians may spend up to 2 hours carefully trimming each fillet with specialized knives, meticulously removing connective tissue, excess fat, and any sections likely to shrink or dry out during reheating. Only cuts with uniform thickness, fine grain, stable fat distribution, and high moisture retention capacity are approved for premium cabins, a filtering step designed to ensure consistency across thousands of high-end meals. Beyond filet steak, kingfish is another premium option favored by airlines for its stable texture and refined flavor. To prepare kingfish for in-flight service, the process begins with a fresh fish stock, made by simmering fish bones with vegetables, herbs, and peppercorns to build a deep flavor base. The fish is brushed with oil, coated in a seasoning blend that includes brown sugar, then quickly seared for about 1 minute per side, just enough to create a light caramelized crust while locking in moisture. In parallel, butter and flour are cooked into a sauce base, combined with the fish stock, cream, lemon, and cayenne pepper. Each day, this kitchen is capable of preparing over 3,000 portions of kingfish in under 5 hours, ensuring a steady supply for continuously departing flights. In the pastry section of an airline catering facility, both scale and precision are pushed to their limits. Each hour, the production line can turn out up to 10,000 croissants, while simultaneously finishing handcrafted items such as fuka pastries, donuts, and cream cakes in a wide range of flavors, from vanilla and chocolate to fruit-based variations. Alongside large-scale production, pastry chefs continue to innovate, developing new desserts each quarter, including chocolate brownies and floating custard cakes in vanilla sauce. These recipes are streamlined for airline service while preserving a sense of refinement and premium quality. Every dessert is engineered to maintain its shape, texture, and flavor under flight conditions, where temperature, humidity, and service timing constantly fluctuate. Once completed, each pastry is rapidly chilled and carefully packaged to meet aviation standards, minimizing deformation and quality loss throughout transport, storage, and reheating before being served to passengers in the air. Once the meals are fully packaged, they immediately leave the kitchen through a closed logistics flow, moving directly from the ground to the aircraft within a strictly programmed time window. From that moment, the race against time enters its final phase, and responsibility for completing the meal is handed over to the cabin crew. Every autumn, nearly 3.4 million metric tons of apples pour into Washington, a large portion of which consists of utility-grade apples, not beautiful enough for store shelves, yet perfectly crisp and sweet, making them the golden ingredient for surprisingly rich and flavorful juice batches. Before processing, the apples are moved into massive recirculating water tanks, where a combination of aeration and dilute chlorine is used to knock off dirt and impurities. The cleansing process then continues with high-pressure water jets, which meticulously scrub every small crevice on the skin. After the rigorous cleaning process is complete, the fresh apples are transferred onto a dewatering conveyor system. Here, they pass through a system of rotating and vibrating rollers, which helps completely drain the surface water. This process is often combined with a gentle stream of warm air to ensure the apples are dried most effectively, without compromising the quality of the fruit. Next, the apple mill operates as a cell disruption chamber. Inside, a rotating shaft is fitted with dozens of high-speed cutting blades or crushing hammers. As apples drop in, centrifugal force presses them against a stainless steel sieve, simultaneously crushing them and controlling the particle size. This specific design helps preserve the apple's full flavor without any metallic off-taste from rusty steel, minimizes heat generation, and protects the natural enzymes before pressing. Thanks to the intense pressure from a high-capacity screw press system, all the liquid is extracted from the mash. However, to achieve industrial-grade clarity, the decisive step is microfiltration using stainless steel pipes. At this stage, only small molecules like water and sugar can pass through. Up to 99% of microorganisms, enzymes, and colloidal particles are securely trapped on the surface. But did you know that the 100% juice label on apple juices today doesn't necessarily mean they are pressed entirely from fresh apples? Many products are actually reconstituted concentrates, or even blended with grape or pear juice to lower costs. Therefore, every drop of original, unadulterated apple juice is not only distinct in flavor, but also reflects a level of honesty that not every production line dares to uphold. After harvesting, pineapples have a maximum of only 4 hours to be delivered to the factory before natural enzymes and sugars begin to soften the core. In the past, processing pineapples was a challenge due to the thick rind, deep-set eyes, and fibrous core. But today's state-of-the-art technology has thoroughly overcome these weak points, making the entire procedure significantly gentler. After being cleaned by high-capacity, swirling spray nozzles, workers only need to trim both ends to create flat surfaces. The delicate remainder is entrusted to the gripping mechanism and rotary blade system. Stable clamping pressure keeps the fruit perfectly centered, while the blade cuts precisely into the deep-set eyes while maintaining minimal material waste. The entire operation takes less than 5 seconds, replacing manual effort that could sometimes take tens of minutes. But that efficiency is not the final goal. On modern production lines, a single pressing cycle is sufficient. to simultaneously strip the peel and core the center. Thanks to the self-centering blade system, the pineapple emerges from the machine as a cylindrical block, with a consistency error of only a few millimeters. From here, the pineapple is sliced and packaged entirely by machine, ready to enter the bags of pre-cut fruit, the highest consumption segment in the entire fresh fruit supply chain every day. Before becoming a sweet icon, the journey of the strawberry begins in the temperate fields of California, where farmers spend more than 6 months of continuous care before harvesting the first crop. Workers use small tipped knives to remove the stem along the contour of the calyx, avoiding the white flesh inside, which bruises easily. Damaged berries are then discarded, since even a single bruised fruit in a batch can alter the flavor of the whole batch of jam and cause it to discolor more quickly. The next step is ultra-fast freezing at temperatures dozens of degrees below zero. This step is costly because it requires high-capacity freezing chambers running continuously, but in return, it is the key condition that allows all the water to crystallize into tiny ice crystals, helping lock in the bright red color, the sweet-tart balance, and the fibrous structure. The strawberries are thawed slowly to prevent breakage, then cooked at a temperature below boiling. This heat is enough to concentrate the sugars without destroying the organic acids and aromatic essential oils, the elements that create the true strawberry flavor. During cooking, the sugar gradually seeps into each layer of fruit, giving the jam a supple, glossy texture while still preserving the visible strands of fruit, completely different from jams made with gelatin, which have a uniform, depthless structure. When the jam reaches the ideal consistency, it is poured into glass jars and sealed with tin lids while still hot. The tin lids are not just aesthetic. Once tightened, they create an almost vacuum-like environment that prevents microbial intrusion without the need for preservatives, and they do not react with fruit acids, so the aroma and flavor remain intact over time. With this rigorous process, in Europe alone, where annual strawberry jam consumption reaches up to 480,000 tons, whole fruit strawberry jam has become so popular that nearly every household keeps a jar in the kitchen. Right after sugarcane juice leaves the press, it still contains fibers, dust, and tiny organic compounds, impurities invisible to the naked eye. For this reason, a very small amount of lime is added to pull all impurities down to the bottom. This reaction works much like the clarification process used in Heineken's beer, or the clarification of Tropicana's fruit juice, using a chemical agent to bind and coagulate impurities, allowing the sugarcane juice to become crystal clear and ready for the concentration stage. As the juice passes through a multi-stage evaporator system, only the water disappears. The sugars gradually thicken into a golden syrup. Most major brands invest heavily in this stage, because the evaporation rate and vacuum level directly determine the color, aroma, and stability of the final sugar. In the crystallization phase, seed sugar crystals are added as initial nuclei for the solution to cling to, gradually growing into well-defined crystals. The formation of the first sugar grains is similar to the way sea salt or crystal glass is cultivated, a single guiding crystal for the entire batch. Once crystallized, the mixture enters a centrifuge, where the crystals are separated from the molasses. Raw golden sugar retains 3 to 5% cane molasses, giving it a natural caramel aroma, while refined white sugar reaches 99.9% sucrose, precisely the purity level required by confectionery companies to ensure consistent flavor across millions of products. Even after centrifugation, the crystals remain slightly moist and prone to clumping, so they are dried to an optimal moisture level. For segments requiring absolute whiteness, such as sugar used for marshmallows or fondant, the crystals are even redissolved, filtered through multiple layers of materials, and centrifuged again to eliminate any remaining pigments. The final result is pure white sugar granules, so uniform that they look almost identical. But here's the interesting part. They were never truly identical. Natural variation between crystals is merely minimized through controlled crystallization and industrial grading systems, making them appear perfectly consistent to the human eye. Tomato sauce is among the most widely consumed vegetable-based products in the world, thanks to its limitless versatility. It appears in thousands of culinary recipes, but few people know that behind a seemingly simple bottle of sauce lies an entire industry operating under global standards. The journey begins when tens of tons of tomatoes are unloaded onto the factory's receiving conveyor to enter the washing stage. Here, the flume water system is considered the international standard. Water is pushed into a gentle, controlled current, strong enough to sweep away impurities, yet soft enough not to bruise the extremely delicate flesh. For tomato sauce, factories often prioritize the hot break method, rapidly heating the crushed tomatoes to a very high temperature to deactivate enzymes and preserve a stable thickness. The tomatoes are fed into industrial grinders, where steel blades turn them into a fine puree. Immediately afterward, the mixture is passed through sieves and membranes to remove seeds and skins, an essential step that ensures a smooth sauce, stable color, and long shelf life. The tomato puree is cooked in steam-jacketed steel kettles, stirred continuously to prevent burning. Meanwhile, onions and garlic are sautéed in sunflower oil. On average, a 1,000-liter batch of tomato sauce requires about 9 kilograms of onions and garlic before being blended with the tomato puree, along with salt, sugar, spices, and vinegar. Now that we've met the blueberry, let's head out to the fields where the magic happens. Harvesting 680 million pounds of anything is no small feat, and when it comes to blueberries, it involves a blend of tradition, technology, and a whole lot of hard work. When it comes to picking blueberries, farmers have a couple of tricks up their sleeves. The first, hand harvesting. Despite the wonders of technology, many farmers still rely on the tried and true method of hand picking, especially for berries destined for the fresh market, where appearance is everything. Teams of pickers move through the fields, gently plucking the ripe berries and leaving the unripe ones to mature. Hand harvesting is labor-intensive but allows for a more selective pick, ensuring only the best berries make it into the basket. Plus, it's easier on the bushes and reduces the risk of bruising the delicate fruit. For wild blueberries, farmers have a few tools to help them harvest. They look pretty cool, don't they? We also have mechanical harvesting. For large-scale operations, mechanical harvesters are the go-to. Picture a giant machine that straddles the rows of blueberry bushes. As it moves along, it gently shakes the bushes, causing the ripe berries to fall onto catch plates before being conveyed into large bins. It's like a berry-friendly earthquake, minus the destruction. These machines are marvels of agricultural engineering, designed to maximize efficiency while minimizing damage to the plants and fruit. They can harvest acres of blueberries in a fraction of the time it would take a human crew, which is crucial when dealing with such massive quantities. Imagine vast stretches of land, blanketed with rows upon rows of blueberry bushes, their branches heavy with clusters of ripe berries. States like Michigan, Oregon, Washington, Georgia, and New Jersey are the blueberry powerhouses of the U.S., thanks to their ideal climates and soils. Blueberry season typically runs from April to September, but the exact timing varies by region. Farmers keep a keen eye on their crops, waiting for that perfect moment when the berries reach peak ripeness. Sweet, firm, and full of flavor. Harvest season is a bustling time on the farm. Workers often start at dawn to beat the heat, armed with buckets and an eye for the perfect berry. It's hard work, but not without its charms. There's a certain camaraderie among the pickers, sharing stories and laughter as they move down the rows. And let's be honest, sneaking a fresh berry or two straight from the bush is one of the perks of the job. Once the berries are picked, their journey is far from over. Next stop, the factory, where they'll be cleaned, sorted, and packaged. This stage is all about preserving quality and getting the berries ready for their debut on supermarket shelves or as ingredients in your favorite foods. The significance of modern technology and machinery in this entire process cannot be overstated. Advanced cooling systems are essential for rapidly reducing the temperature of large volumes of berries, which is critical for slowing down enzymatic activity and preventing spoilage. Automated washing systems ensure that berries are cleaned efficiently without being damaged, a task that would be impractical and less hygienic if done manually. Optical sorting technology can process thousands of berries per minute with remarkable precision, something that would be impossible with manual sorting. Moreover, modern machinery contributes significantly to food safety. Equipment is designed with sanitation in mind, featuring materials and surfaces that are easy to clean and resist bacterial growth. Automated systems reduce the amount of human contact with the product, lowering the risk of contamination. In addition to quality and safety, technology enhances efficiency and sustainability in the processing of blueberries. Energy-efficient machines reduce power consumption, and precision equipment minimizes waste by ensuring that only defective berries are removed. Some facilities even utilize waste products like berry skins and rejected fruit for secondary uses, such as natural colorants or animal feed, promoting a more sustainable operation. After about 2 months of maturation in the fields, the broccoli heads begin to show, uniform in their deep green color. When they reach a diameter of 4 to 8 inches, it's time to harvest. The harvest of broccoli is when things really get lively in the fields, especially when it comes to bringing these beautiful green heads from the farm to the store. There are 2 main methods of harvesting. Farmers can harvest manually with the help of conveyor belts or use machinery. Each method has its own unique appeal. So join us as we explore each method in detail. Harvesting broccoli manually, but with the aid of a conveyor belt, is a perfect blend of human effort and technology. Farmers, armed with sharp shears, walk along the broccoli rows like skilled gardeners, meticulously inspecting each head with high focus. When they find a broccoli head that has reached the ideal size, they gently cut it from the stem. However, the distinctive feature here is the mobile conveyor belt running right alongside them. After cutting, the broccoli doesn't need to be clutched tightly or piled at their feet. Instead, it is placed directly onto the conveyor belt attached to a slowly moving tractor. The conveyor takes on the task of transporting the broccoli to a large container at the back of a truck, minimizing the need for manual labor. This system not only makes the work easier, but also optimizes productivity, ensuring each broccoli head is handled carefully and quickly. For large fields or when farmers want to save time, a harvesting machine is the optimal choice. Imagine this as a miraculous machine that can harvest rows of broccoli in the blink of an eye. The harvesting machine rolls across the field with mechanical arms like giant fingers, gently gripping each broccoli plant at the base. Then, a decisive cut separates the plant from its roots and lifts it onto a separate conveyor belt. This conveyor belt moves the broccoli to an on-machine sorting area. Here, farmers wait to inspect each broccoli head and remove any unnecessary outer leaves. The process is very quick and efficient as they continue to move along the conveyor and into a container at the back of the truck. Besides, robotic broccoli harvesting represents a breakthrough in modern agriculture. The machine is equipped with smart sensors that precisely identify broccoli heads that have reached the ideal size and ripeness. Upon detection, the robot moves to the broccoli heads and automatically cuts them from the stem quickly and gently, also removing any unnecessary leaves. All harvested broccoli is then transported directly into a container, ready for the next sorting and packaging stage. After broccoli is harvested, it undergoes an immediate cooling process using crushed ice to preserve its freshness and quality. This method, known as hydro-cooling, involves packing the broccoli in containers filled with ice to rapidly lower its temperature. The ice not only helps retain the vegetable's vibrant green color and crisp texture, but also prevents spoilage by slowing down enzymatic activity and bacterial growth. This step is crucial to ensure the broccoli stays fresh and nutritious during transportation to markets and consumers. Besides, after harvesting, the broccoli heads begin their journey at the processing plant, with the first step being sorting. Broccoli heads are placed on a conveyor belt where workers carefully inspect and sort them based on size, color, and quality. Only the freshest and most uniform broccoli heads continue to the next step. The broccoli heads are trimmed to remove excess stems, ensuring they meet size and shape standards for packaging. This step also helps maintain uniformity for easier handling and presentation. Larger broccoli heads are chopped into smaller florets using precise cutting machines, or can also be packaged directly. The processed broccoli is then carefully packed into airtight bags or containers to preserve freshness. These packages are sealed and labeled, ready for distribution to markets, direct delivery to supermarkets by truck.